January 17th, 1941. Akron, Ohio. The morning air smelled of sulfur and coal smoke. Inside the sprawling brick complex of Goodyear Tire and Rubber Company, a chemist named Willard Humphrey stood before a vat of viscous amber liquid, watching it cool under dim industrial lights. The substance bore no resemblance to the rubber that had built empires, no tropical scent of latex, no memory of distant plantations. This was something else entirely. Something born not from trees, but from the earth itself, from oil, from lime, from desperation. Outside, beyond the frosted windows, America was a nation caught between two worlds. Europe burned, Asia bled, and in the silence of American neutrality, a single terrifying truth was becoming impossible to ignore. The United States of America, the industrial colossus that had mechanized the world, possessed almost no natural rubber of its own. 97% of the world's rubber supply came from a region the size of Texas, stretching across British Malaya, the Dutch East Indies, and French Indochina, fragile necklace of plantations dangling along the equator 6,000 miles from American shores. And in the war rooms of Tokyo, military planners were already drawing red circles around those very islands. Humphrey did not know this yet, but he understood what the substance in his vat represented. It was insurance. It was defiance. It was the chemical embodiment of American ingenuity, refusing to bow before the tyranny of geography. Rubber had ruled the 20th century with a grip more absolute than steel. Without it, there were no tires, no gaskets, no belts, no hoses, no seals. Without it, trucks could not roll, planes could not fly, ships could not function. A single B-17 bomber required half a ton of rubber. A battleship demanded 75 tons. A tank needed nearly a ton just for its tracks and fittings. Rubber was not merely a material. It was the sinew of modern warfare, the silent ligament binding together every machine of war. And America had none. The British controlled Malaya. The Dutch controlled the East Indies. The French held Indochina. Together, these colonies produced over 90% of the world's natural rubber, harvested by the hands of millions of laborers tapping the bark of heavier Brasiliensis trees under tropical suns. The system had seemed eternal, indestructible, as permanent as the empires that built it. American corporations had invested heavily in these plantations: Goodyear, Firestone. Us Rubber all had stakes in the great green factories of Southeast Asia. The rubber flowed to Akron, to Detroit, to every factory floor in America. And no one questioned the supply. No one imagined it could simply vanish. But in the autumn of 1940, as German U-boats prowled the Atlantic and Japanese armies marched deeper into China, the unthinkable began to whisper at the edges of American consciousness. What if the supply lines broke? What if the plantations fell? What if, overnight, the flow of rubber simply stopped? The US government had begun stockpiling in 1940, purchasing every available pound of crude rubber, driving prices skyward. By the end of that year, America had amassed over 500,000 tons a mountain of raw latex stacked in warehouses from coast to coast. It seemed like abundance. It was an illusion. Analysts calculated that in the event of war, that stockpile would last less than 2 years. After that, the American war machine would grind to a halt, its tanks immobilized, its aircraft grounded, its economy strangled by the absence of a single organic compound. The search for alternatives had begun decades earlier, long before the threat of war made it urgent. In the 1930s, German chemists, anticipating their own isolation, had developed Buna rubbera, synthetic, made from coal, limestone, and petroleum. It was crude, expensive, and inferior to natural rubber in almost every way, but it worked. It kept German vehicles moving. It proved that rubber could be conjured from stone and fire, that the laws of nature could be rewritten by human will. American chemists watched with a mixture of admiration and dread. Neoprene was not born from war. It was born from accident in April 1930. A young chemist named Wallace Carruthers, working in the experimental labs of DuPont in Wilmington, Delaware, had been investigating the polymerization of acetylene, a volatile gas derived from calcium carbide and water. Carruthers was not looking for rubber. He was probing the fundamental architecture of molecules, seeking to understand how small chemical units could link together into long chains, forming entirely new substances. His work was theoretical, philosophical, almost an inquiry into the nature of matter itself. But one of his assistants, Arnold Collins, made a mistake. He left a sample of chloroprene, a derivative of acetylene, sitting in a beaker over a weekend. When he returned on Monday morning, the liquid had transformed. It had polymerized spontaneously, thickening into a rubbery solid that stretched and bounced like natural latex. Collins showed it to Carruthers. Carruthers recognized it immediately. This was not rubber, but it behaved like rubber. And unlike natural rubber, it resisted oil, heat, and weathering with a tenacity that organic latex could never match. DuPont patented the substance in 1931 and named it Neoprene. Later, they renamed it Neoprene, a name that sounded modern, synthetic, American. It was marketed initially as a specialty material for oil-resistant hoses and gaskets, applications where natural rubber failed. Production remained small. Neoprene was expensive, roughly 5 times the cost of natural rubber. It was a curiosity, a niche product for industrial purists. But when war clouds gathered over the Pacific, neoprene ceased to be a curiosity. It became a lifeboat. Goodyear had always been different. Founded in 1898 in Akron, Ohio, it had grown into the largest tire manufacturer on earth by embracing both innovation and scale. While competitors relied entirely on natural rubber imported from the tropics, Goodyear's engineers had been experimenting with synthetic alternatives. Since the early 1920s, they understood viscerally what policymakers in Washington were only beginning to grasp: dependence on a single distant source was not a business model. It was a vulnerability. When DuPont announced neoprene in 1931, Goodyear licensed the formula immediately. By 1935, Goodyear had constructed its own neoprene production facility in Akron, refining the process, scaling up output, testing the material in everything from conveyor belts to submarine cables. The work was slow, methodical, unglamorous. There was no fanfare. Neoprene remained a niche material, a hedge against an uncertain future. And then the future arrived. On December 7, 1941, Japanese carrier aircraft struck Pearl Harbor, shattering the illusion of American invulnerability. 4 days later, Germany declared war on the United States. And within weeks, the nightmare scenario that had haunted military planners became reality. Japanese forces swept south through Southeast Asia with devastating speed. Hong Kong fell on Christmas Day. Manila fell on January 2nd. Singapore, the supposedly impregnable British fortress, fell on February 15th, and by early March, the Dutch East Indies, the heart of the world's rubber supply, had surrendered. The plantations of Malaya and Java, which had produced over 90% of the world's rubber, were now in Japanese hands. The supply line was not disrupted. It was severed in Washington. Panic set in. The stockpile that had seemed so vast in 1940 was now a ticking clock. At the current rate of military consumption, America had 18 months of rubber remaining. After that, the war effort would collapse. Tanks would sit immobilized. Aircraft would be grounded. Ships would languish in port. The entire mechanized arsenal of democracy would rust into silence for lack of a single material. President Franklin Roosevelt declared rubber a strategic crisis. On June 13, 1942, He announced nationwide gasoline rationing, not because America lacked gasoline, but because driving consumed tires, and tires consumed rubber. A nationwide speed limit of 35 miles per hour was imposed to extend tire life. Scrap rubber drives swept the nation. Citizens donated old tires, rubber boots, garden hoses, anything that could be melted down and reclaimed. Children collected rubber bands. Boy Scouts went door to door, filling trucks with the detritus of civilian life. But scrap was not enough. Rationing was not enough. America needed production. It needed synthesis. It needed to build an entirely new industry from nothing. And it needed to do it faster than any industrial project in human history. The government turned to Goodyear. The directive was simple and impossible. Produce synthetic rubber in quantities sufficient to supply the entire American military and civilian economy. Do it within 2 years. Do it without disrupting existing war production. Do it or lose the war. Goodyear's response was equally simple. We already know how. Neoprene, the oil-derived synthetic that had languished as a specialty product for a decade, suddenly became the blueprint for survival. But neoprene alone was not enough. It was too expensive, too specialized. What America needed was a general-purpose, synthetic rubber something that could replace natural latex in tires, belts, seals, every application where rubber was essential. And the formula for that material already existed, developed years earlier by German chemists and refined by American researchers at Standard Oil and Firestone, that it was called GRS, Government Rubber Styrene, a copolymer of butadiene and styrene derived from petroleum. It was not as good as natural rubber. It was stiffer, less resilient, harder to process. But it worked. And more importantly, it could be made in America, from American oil, in American factories. The challenge was scale. In 1941, total American production of all synthetic rubbers, neoprene, experimental compounds amounted to less than 8,000 tons per year. America's annual rubber consumption exceeded 600,000 tons. The gap was not a gap. It was an abyss. The government allocated $1 billion to build 15 synthetic rubber plants across the nation, from Louisiana to California. Goodyear was awarded contracts to build and operate multiple facilities. Ground was broken in the summer of 1942. Construction proceeded around the clock, 7 days a week, under floodlights and guard towers. Steel was diverted from battleship construction. Concrete was poured in quantities that rivaled the Hoover Dam. Chemical engineers, many of them fresh from university, were handed blueprints and told to turn theory into millions of pounds of rubber. The ingredients were brutally simple: petroleum, sulfur, lime, and heat. Crude oil was cracked into butadiene. Styrene was synthesized from benzene. The two were polymerized together in vast reactors, forming long molecular chains that mimicked the structure of natural latex. The resulting substance, GRS, was coagulated, washed, dried, and belled into blocks that looked, smelled, and handled almost like the rubber that once came from trees. Almost, but not quite. The soldiers who received tires, made from GRS in 1943, did not care about molecular chains or polymerization. They cared that the tires lasted. And at first, they did not. Early batches of synthetic rubber were harsh, inflexible, prone to cracking in extreme temperatures. Tires made from GRS wore out faster than natural rubber tires. They heated up on long drives, sometimes bursting under the stress of weight and speed. Tanker drivers in North Africa reported tread separation. Bomber crews in the Pacific complained that synthetic tires degraded faster in tropical humidity. There were failures, accidents, deaths. Engineers raced to improve the formulation. They adjusted the ratio of butadiene to styrene. They experimented with different polymerization temperatures. They added carbon black for reinforcement, antioxidants to prevent degradation, plasticizers to improve flexibility. The process was trial and error on an industrial scale, each adjustment tested in real-world conditions under the pressure of a war that could not afford to wait. By late 1943, the problems had been largely solved. Goodyear tires were not as good as natural rubber tires, but they were good enough. They held up under the weight of tanks grinding across the deserts of Libya. They carried trucks over the frozen roads of the Russian front. They landed aircraft on the steel decks of carriers in the Pacific. Slowly, grudgingly, the synthetic rubber proved itself. By 1944, America was producing over 800,000 tons of synthetic rubber per year, more than the entire world had produced of natural rubber before the war. The factories never stopped. The reactors never cooled. The supply lines that had once stretched across oceans now ran through pipelines and refineries, drawing rubber from the same wells that fueled the bombers and tanks. Oil had become everything: fuel, rubber, plastic, power. The earth itself was being transformed into the sinew of victory. In the jungles of Malaya and Java, Japanese occupation forces struggled to maintain the rubber plantations they had captured. The trees still stood, the latex still flowed, but without the global supply network, the rubber rotted in warehouses. Japanese chemists attempted to synthesize their own rubber from rice alcohol and limestone, but production remained minuscule, insufficient even for domestic needs. Japanese military vehicles began cannibalizing tires from civilian trucks. Rubber was rationed so strictly that soldiers in the field were ordered to repair tires with improvised patches made from leather and canvas, the abundance they had sought to control by conquest was slipping through their fingers, while across the Pacific, America was conjuring it from stone and fire. This was the paradox that imperial planners had never anticipated. They had believed that seizing the plantations would cripple America, that controlling the source would mean controlling the outcome. They had underestimated the stubbornness of American engineers, the creativity of American chemists, the sheer industrial will of a nation that refused to be bound by the limitations of nature. When German officers examined captured American vehicles in 1944, they noted with grim fascination that the tires bore no trace of natural rubber. Every gasket, every seal, every belt was synthetic. The Americans had built an entire parallel material economy in less than 3 years. It was a feat that German industry, for all its early achievements in synthetic rubber, had never matched at such scale. And it was a feat that signaled something deeper than industrial capacity. It was evidence of a philosophical difference. The Axis powers had waged war to seize resources they lacked: toil, rubber, metals, food. They believed that control of raw materials equaled power, but America had demonstrated something more dangerous: the ability to invent resources that did not exist in nature, to transmute one substance into another, to bend chemistry itself to the demands of war. This was not conquest. It was creation. Wallace Carruthers never saw the triumph of the material he had helped invent. Struggling with depression, he took his own life in April 1937, 5 years before neoprene and its descendants would help win a world war. His laboratory notebooks, filled with meticulous diagrams of molecular chains, became blueprints for a new industrial age. His accidental discovery, the rubbery substance that formed in a forgotten beaker, became the seed of an industry that would outlast the war and reshape the modern world. By 1945, when Japan surrendered and the guns fell silent, synthetic rubber had become the standard, not the substitute. Even after the plantations of Southeast Asia were liberated and natural rubber began flowing again, America did not return to the old ways. The synthetic rubber plants kept running. The formulas kept improving. Neoprene, GRS, and their descendants became permanent fixtures of the industrial landscape, their production exceeding natural rubber within a decade. the tire that rolled off the assembly line in Akron in 1950 owed nothing to the jungles of Malaya. It was born from oil wells in Texas, refineries in Louisiana, chemical plants in Ohio. It was harder, more durable, more consistent than any tire made from tree sap. It was, in every sense, a product of human will imposed upon the raw chaos of organic chemistry. The symbolic weight of synthetic rubber extended far beyond logistics. It became, in the years after the war, a parable of American exceptionalism, a story told in classrooms and boardrooms about the power of innovation to overcome natural limits. It was invoked during the Cold War as evidence of capitalist superiority, proof that free markets and free minds could outproduce command economies. It was cited in debates over energy independence, environmental policy, technological progress, but the deeper truth was more complex and more troubling. Synthetic rubber had freed America from dependence on distant plantations, but it had also bound the nation more tightly to oil. Every ton of GRS required barrels of petroleum. The more America drove, the more rubber it needed. The more rubber it needed, the more oil it consumed. The tire and the fuel tank became inseparable, two halves of a single industrial logic that would define the second half of the 20th century. The plantations of Malaya, once the source of an empire's wealth, faded into obscurity. The tappers who had worked under colonial overseers found themselves unemployed, their skills obsolete, their labor replaced by catalysts and pressure vessels half a world away. The trees still grew, the latex still flowed, but it no longer mattered. The world had moved on. In Akron, the factories expanded. Goodyear became not just a tire company, but a chemical giant, producing thousands of synthetic compounds for every conceivable application. The city, once known for processing rubber harvested by hand in tropical heat, became a monument to industrial chemistry, a place where molecules were designed, patented, and mass-produced with the precision of clockwork. And somewhere in the archives of those factories, in filing cabinets and microfilm reels, the original lab notes from 1930 still existed. Wallace Carruthers' careful handwriting, documenting the properties of a substance that formed by accident. A footnote that became a foundation. A mistake that became a strategy for survival. The last veteran of the rubber crisis. A chemist named Harold Morton who had worked the night shifts at the Baytown, Texas synthetic rubber plant in 1943, died in 2018 at the age of 97. In his final interview, conducted by a local historian, he was asked what he remembered most vividly about those years. He did not mention the long hours, the danger of working with volatile chemicals, the pressure of knowing that failure could cost lives on distant battlefields. He mentioned the smell, the acrid, petroleum temps of butadiene and styrene mixing in the reactors. A smell that, he said, was nothing like the earthy sweetness of natural latex. It smelled like the future, he said, like something made rather than grown, like defiance. That smell lingered in Akron long after the war ended, drifting over the brick factories and modest homes, a permanent reminder of what had been accomplished in those desperate years. It was the smell of limestone heated to incandescence, of crude oil fractured into its constituent parts, of sulfur binding chains of carbon into elastic networks. It was the smell of nature rewritten by necessity. And in the end, that was what synthetic rubber represented, not merely a material, but a declaration. A refusal to be constrained by the accidents of geography, by the distribution of trees across the tropics, by the old logic of empire and extraction. It was chemistry as liberation, industry as ideology. The irony, of course, was that this liberation came with its own chains. Dependence on oil, environmental degradation, the unseen costs of a petrochemical economy that would haunt future generations. But in 1941, standing in a cold Akron factory before a vat of amber liquid, Willard Humphrey could not have known any of that. He knew only that his country needed rubber, that the plantations were an ocean away, and that the substance cooling before him represented a way forward. He reached out and touched it. It was warm, pliant, resilient. It was, in every way that mattered, rubber, and it had come not from soil, but from stone. Not from life, but from the dead remains of ancient forests, compressed and transformed by millennia of heat and pressure deep beneath the earth. In a sense, it was still a gift from trees. Just trees that had lived and died 300 million years before the first human hand ever tapped the bark of a heavier Brasiliensis. Rubber, it turned out, was never about trees. It was about chains. Long, flexible, resilient chains that could be grown in a jungle or built in a reactor. The difference was only one of time and technique. And America, in its moment of greatest need, had learned to build those chains faster than any empire in history. That was the lesson Japan learned too late. That was the miscalculation that doomed the Axis powers. They had conquered the plantations, but they had lost the chemistry. They had seized the present, but America had invented the future, and in that invention, in those vast reactors humming through the nights of 1943 and 1944, in the ceaseless flow of synthetic rubber pouring from American factories, there was a truth larger than strategy or logistics. It was the truth that had always defined America, even in its darkest hours, that limits were not permanent, that resources could be created, that the world itself was not fixed but malleable, waiting to be reshaped by will and ingenuity. The tire that rolled a Sherman tank through the ruins of Berlin in 1945 was not made from the sap of distant trees. It was made from oil, from lime, from sulfur and heat and human determination. It was synthetic, artificial, unnatural, and it was, in every sense, a victory.